Welcome to the Thread Group webinar to talk about Thread 1.3.0. We will get started in less than a minute to finalize letting people join the webinar. For today's webinar, let me cover a few logistic items. You will be placed on mute by the organizer through the presentation. If you have questions anytime during the presentation, you can type those into the Q&A window as shown on this screen on the right side. We will address the questions at the end of the presentation in the Q&A section, but it will all be done through the chat window. We'll answer the questions, but the questions will come in through the chat window. And then after the webinar, there will be a recording of this provided and made available on the Thread Group website. So now let me introduce our speakers for today. I will kick it off and give you some topics, present on some topics. The other presenters are Jonathan Wee, who is VP of Technology of Thread Group, and Tom Sorelli, who's Director of Certification of Thread Group, Gabe Castle, Principal Product Manager at Eero, Nathan Dyke, Chief Product Officer at Nanoleaf, and Mark Borens, CTO, Co-founder, MMB Networks. For today's agenda, we're going to kick it off with an introduction about Thread, then pass it over and talk about Thread certification, give you an overview of what is included in Thread 1.3.0, then provide some examples on Thread 1.3.0, and review Matter with Thread products, and talk about what's coming next, and then we'll have the summary and do the Q&A. All right, so let's dig into the overview of Thread. Okay, so what is Thread? Thread is a low-power, secure, and future-proof mesh networking technology. Thread was designed from the ground up to address IoT products and provide a reliable, scalable, low-power, and secure solution for how to connect devices together. So it was built for IoT, again, keeping in mind the low power requirements, security, and to have a robust network. It is a global solution, so Thread is an open standard. Any members of Thread Group can deploy Thread in their products and contribute to the development of the Thread roadmap. We target Thread in the smart home market. It also supports applications in the smart building industry. And Thread was built on IP, or the Internet Protocol. The driving force behind that was to provide a point of convergence and to enable coexistence between other technologies built on IP. And with all of that, Thread provides a flexible and future-proof technology. It enables interoperability, so it gives product manufacturers who deploy Thread-based products a future-proof capability of knowing that their products will interoperate with other products. Okay, now let me give you a little bit more detail about what Thread delivers. So again, it is a low power mesh network that's designed to connect smart devices in homes and buildings. It is built on well deployed, widely available technologies that are proven and adopted in the market. So it uses IPv6, like I discussed on the earlier slide, and also it uses an existing IEEE 802.15.4 radio that's available in silicon from multiple providers. It has been architected to provide simple and secure ways of adding devices and removing devices from a network, and to keep the communications between the devices secret with a proof of identity. It is trusted and tested to be able to control devices in smart homes or to large office buildings that are 1,000 people, and makes it scalable in that sense. And on the right side, you see a diagram of a network stack diagram to show exactly what Thread covers. So it's built on the basic foundation of an IEEE 802.15.4 radio, so the MAC-PHY that is available again by many silicon providers. And then on top of that, we have the 6LoWPAN, the IP routing, and the security and commissioning, and that is what is included in the Thread protocol. Thread is designed purposely to not include an application layer. Because it's IP-based, it can work with multiple application layers and work with multiple at the same time. Digging a little deeper into how then Thread is deployed in a smart home type network. This is a diagram that illustrates what you would expect to see in a typical smart home. So you'll have many devices, and we're using Matter as an example here. So what you see in the circles on the bottom of the screen is the home network made up of low power devices using the Thread technology with Matter application on top of that. And those devices can communicate directly to each other. Again, because it's IP based, there's direct device to device communication without the need of going through any translators or hubs. The Thread network then also interfaces to other IP networks through what we call a Thread border router. And it's really important to understand that a Thread border router, unlike Wi-Fi access points, is not a device type. A Thread border router is a function that can be embedded into a number of existing device types, like Wi-Fi access points, devices that are always powered and can support multiple networks. Then you have your Wi-Fi access point, which can communicate to other devices that would be using different protocols like Wi-Fi or Ethernet. In addition, you can support other devices that are not IP-based through bridges. So this is what a typical network would look like, and I wanted to highlight some of the badging you see on here. So a Thread device can act as an end device where it's a battery operated device, and so because of that, it can be in a turn down or sleepy mode. It receives and sends information. It does not route data. The orange circles show the Thread devices that are powered and act as mesh extenders. So that means that they are routing traffic through the network. And then we discussed the border router already. An important tool that we have to help enable you and users of the Thread technology really understand what they have and what part of the Thread network they have. On the left, you see logos that are built on Thread. That means that a device has passed all of the Thread certification and it carries the mark as a seal of approval that it has achieved the requirements outlined by the spec. You also see a tag that's attached to the side of that logo that says requires border router. So if a user buys a sensor that's a Matter with Thread-based sensor, and they can see that it says requires border router, they also need to have in their home some sort of device that acts as a border router. And there's a different badge on the right side here that illustrates that it is a border router. So on the left, you have marks to help consumers know that they will need a border router in their home. And on the right, these are the badges that you would see on a device to identify that that device has border router functionality. Now, let me pass it over to Tom to talk about Thread certification.
Thanks, Sujata. Let me give you a quick overview of Thread certification. So one of the cornerstones of Thread is a robust certification program. We've put a lot of effort into our testing. We have a lot of conformance coverage, but the key thing that really helps for market success is multi-vendor operability. And we have true interoperability with using at least 3 stacks, 3 reference device stacks in every program that we field. For development reasons or development benefits, we have many certified stacks already available in the market, and we provide fast ramp tools such as an automated Thread test harness to help members move ahead quickly in their testing and be ready to go to test labs. There are a number of reasons behind certifying. One of the most basic ones is that intellectual property rights for using Thread technology are tied to completion of certification. So that's a strong reason, strong benefit for folks to get that done. You get an official Thread Group certificate that indicates your compliance and your operability status. Thread Group will help to promote your certified product on our website and in some of our press releases. There is, of course, as I mentioned, a website. We have a certified product listing on threadgroup.org. And what has been evolving over time is now Thread certification is becoming a prerequisite of many different application layer certification programs, such as Matter. So a number of reasons why members should be looking seriously at pursuing certification with Thread products. There's our website listing there where you can get some more information about certain details. We do operate a global network of authorized test labs. Currently have 10 active test labs. We have Alion in Taiwan, DEKRA in Spain, TÜV Rheinland in Sweden, SGS in Korea and Taiwan, and then UL Solutions in Taiwan, China, Korea, the UK, and California. So in order to certify, you have to have membership in Thread Group. We do have two options, two paths for certification. The most basic one is physical testing of a Thread system. This does cover the network protocol, conformance, and interoperability. It is done physical testing at an authorized test lab. And then for certain applications, certain products, we do have a non-testing option called inheritance, where products can inherit the certification from upstream Thread systems that have been certified in other ways. So this is for products which can reuse those certified Thread systems in an unchanged state, sometimes with self-testing, sometimes with a declaration. Application layers, those are all certified separately via the owning organization that has that app layer or standard. So Thread certification is required separately. So in a Matter example, a Matter with Thread device must have Matter certification completed per the CSA program, and then Thread certification also completed through Thread Group's program itself. One thing I will caution everybody is to engage with Thread certification efforts as early as possible, just so you don't get any surprises at the end as you're trying to race your product to market. We do try to help you go quickly, but it's important that you learn about it as soon as possible and understand how to get through the program successfully. So again, Thread Group membership is your pathway to getting into certification. We do have 3 different membership levels: sponsor, contributor, and implementer. ATL, test lab access, pre-testing access is available to sponsor and contributor levels. Implementer level is basically an inheritance only level. So implementers have access to inheritance, not test labs. And of course, sponsors and contributors also have access to that inheritance level. There are paths for members to get the test harness software and the hardware for all membership levels. The software is free for sponsors and contributors. It is available as a per seat license for implementers, and the testbed hardware itself is available to purchase in the market for any of the Thread membership levels. That concludes my quick overview of Thread certification. So I will turn it over now to Jonathan to go over his Thread 1.3.0 overview. Thank you.
Thanks, Tom. Sorry, trying to advance the slides here. Okay, so what is Thread 1.3.0? All right, so as Sujata mentioned, one of the primary goals of Thread 130 is really to provide seamless response or communication across Matter devices. Matter is an application layer protocol that's built on top of IPv6. And as such, that allows Matter really to build and ride on top of networks composed of different link technologies, and in particular, Wi-Fi and Thread. What this really enables is basically to build networks that take advantage of these different link technologies where they fit most appropriately. So Thread being targeted for low power, low bandwidth devices that need to operate for years on small batteries, and Wi-Fi obviously for higher throughput applications that don't have the same power constraints. So because we're operating on IP, both Thread and Wi-Fi can be used together in a complementary fashion, and it allows Matter to build solutions that take advantage of both Thread and Wi-Fi without the Matter endpoints really even having to understand the difference between Thread and Wi-Fi. All they see is an IP address, and they communicate with it. So that's really one of the advantages with IP, and Thread 130 enables that capability. And more generally, Thread 130 allows Thread devices to seamlessly integrate into existing networks. In a typical home network, for example, we're used to seeing a Wi-Fi network or Wi-Fi/Ethernet network that is bridged, and that typically operates as a single broadcast domain, right? So how do we actually integrate that Thread network into an existing IP network? Well, that happens through a border router. That border router is what provides the connectivity between the Wi-Fi and Thread subnets. Unlike Ethernet and Wi-Fi, we don't just bridge the Thread network onto the Wi-Fi/Ethernet network, largely because we want to shield the Thread network from the higher bandwidth traffic that typically happens on the Wi-Fi network, right? So in this kind of network architecture, that does mean Thread does introduce a new IP subnet into the home, and that's really why Thread 130 places a lot of new features into the border router, because the border router plays such an important role in being able to provide connectivity between Wi-Fi and Thread in a seamless fashion using IP. So let me dive a little bit deeper into the technical workings of the Thread 130. The first I want to focus on is IPv6 reachability. So to enable IP reachability, the first aspect is being able to configure the IP networks with appropriate scoped IPv6 addresses. So IPv6 does have a scoped addressing architecture. Devices by default come up with link local addresses, but those addresses are only sufficient for communicating with devices on the same link. So that means for Wi-Fi devices to be able to communicate with Thread devices, those Wi-Fi devices also need to have an additional IPv6 address that has a large enough scope that allows them to communicate with those Thread devices. So how does Thread 130 enable this? We have to take into account that there are going to be environments where IPv6 is not at all enabled, right? There's no internet service provider that's providing IPv6 prefixes, and there may not be a home access point or router that's able to provide IPv6 configuration onto that network. Now that said, practically all laptops and mobile phones, Linux, Mac OS, Windows, and whatnot, already support IPv6. So really, it's a matter of some device being able to offer a configuration of the appropriate IPv6 information. And so that's one of the areas where Thread 130 plays an important role. The border router, when it attaches to a Wi-Fi network, will actually detect if there's any existing IPv6 configuration on that Wi-Fi network. If there is no existing IPv6 prefix, for example, the border router will locally generate its own IPv6 prefix and begin advertising that prefix such that Wi-Fi devices can self-configure an IPv6 address with the appropriate scope. And then on the Thread side, it has to tell the Thread devices how to route to that IPv6 prefix so that they can get to the Wi-Fi devices. And so on the Thread side, the border router will advertise the prefix that it configured the Wi-Fi devices with as a route into the Thread network. And the same has to happen in the opposite direction, right? The Thread network needs to have an IPv6 prefix of appropriate scope so that Thread devices can self-configure an IPv6 address. And then the border router needs to advertise that route into the Wi-Fi network so that Wi-Fi devices know how to route to Thread. Now, with those in place, both Wi-Fi and Thread devices have the appropriate scoped IPv6 addresses and know how to reach each other through the border router. And that's what enables bidirectional IPv6 reachability. Now, once we have IPv6 addresses and we can deliver IPv6 packets across that border router, the next step is how do we actually discover services being offered by Thread devices and or Wi-Fi devices across the different links, right? So Thread 130 leverages DNS-based service discovery, which is widely used today for many other applications, for example, discovering printers on your local network. But on Wi-Fi and Ethernet today, that's typically done using a technology called multicast DNS. And the way that works is the query goes out as a multicast packet on the Wi-Fi link, and then devices will be listening for those. If they offer a service that's being looked for in that query, then they will respond. The challenge with MDNS is it's a very expensive protocol because it's leveraging multicast. And then secondly, MDNS is only defined for link local scope. So how do you actually discover services that are not on the immediate link, for example, Thread in this case? So there's a couple of challenges here. And again, the Thread 130 border router provides mechanisms that efficiently allow us to support DNSSD in a way that's compatible with existing Wi-Fi and Ethernet hosts. So the first aspect of how that happens in Thread is what's called service registration protocol. So when Thread devices attach to a Thread network, they actually register the set of services with the border router to basically provide the set of services that they're offering. And the border router will then maintain a registry of the services that are being offered by individual Thread devices within that network. And why the border router maintains that registry? It's so that it can respond to MDNS queries on the Wi-Fi network on behalf of those Thread devices. So this technology is called advertising proxy. The border router then listens for those MDNS queries, and rather than just forwarding the MDNS query into the Thread network, which would obviously cost both power and bandwidth on the Thread side, it can just immediately respond to those MDNS queries on behalf of the Thread devices. And by supporting MDNS on the border router, that allows full compatibility with existing Wi-Fi and Ethernet devices that are typically used to using MDNS for discovering services on the local network. So that's for publishing services from Thread devices. How does a Thread device actually discover services that may be offered by Wi-Fi devices? So this is in the opposite direction. So yeah, again, trying to avoid multicast as much as possible on the Thread network, Thread devices will unicast a DNS query to the border router itself. And the border router will then translate that into an MDNS query on the Wi-Fi side. So basically the border router is taking the responsibility and the cost of doing the MDNS query. On the Wi-Fi side, it will collect any responses that it may receive and then provide those responses back to the Thread device. So those were just kind of two of the main technologies that I wanted to highlight in this webinar. One is IPv6 reachability that allows both Thread and Wi-Fi devices to communicate seamless with each other. And then DNS-based service discovery, which allow Wi-Fi and Thread devices again to discover services on their respective networks and other networks as well, without having to incur the cost that MDNS would typically do if we had translated that to Thread. And both of those technologies are technologies that Matter truly depends on, and that really is what allows Matter to be able to communicate seamlessly across both Wi-Fi and Thread using the same application layer framework. All right, so that's an overview of Thread 130 features, and I'd like to hand it off to Mark to provide some examples of 130.
Thanks, Jonathan. Get the slide up here. So when people think about Thread and Matter networks as well, I think people think a lot about consumer-based networks, but one of the other use cases is the commercial space. So think about like high-rise office towers or convention centers. And I just wanted to provide kind of a high-level architecture and use case for that these new Thread 1.3 features are starting to make available. So just to take you through the people through the architecture drawing quickly, in the center you'll see one of MMB's new Thread 1.3 compatible products, our BRD21, and this is a Thread border router that can connect between a Thread wireless network as well as the on-premise local Wi-Fi and Ethernet IPv6 infrastructure. And so now with these new Thread 1.3 IPv6 reachability features, we can actually create connections locally in the building from things like the site infrastructure, like a building management system. It can now natively speak IPv6 all the way to your Thread end devices, such as smart lighting, thermostats, different kind of environmental sensors, and air handlers. And here we're showing both a border router, but also similar to some of the earlier architecture diagrams as well, we can build out that Thread mesh for truly large commercial settings. The other key feature that 1.3 is offering on the service discovery is also critical to this use case. So now we have the ability where the Thread end nodes are able to do native service discovery and find different, let's say, control services from building management systems, or perhaps even other IPv6 connected devices connected via Wi-Fi or Ethernet, but as well, and perhaps even more importantly, IPv6 based building management system now can not only see and control the devices on the local Wi-Fi and Ethernet networks, it can also seamlessly discover the devices on the Thread network and those services as well. And that makes for a much more seamless building management system and a much more robust and advanced, commercial building device control. As well, it should be mentioned, like Jonathan had said, these new 1.3 features would also allow us to implement application layers like Matter seamlessly from the control all the way to the Thread end nodes. I'll be passing it off to Nathan for the next.
Thank you. Let's see if I've got control here. Maybe someone can advance the slide for me here. Perfect. So yeah, to give you guys an idea of how this actually plays out in practice for upcoming application layers like Matter, which Nanoleaf is a part of. Yeah, basically here we can see the DNS space service discovery that Jonathan was talking about in action in the border router. So in this very simplified network diagram, we've got a light bulb, our border router, which is the Nest Hub, and a computer. And the screenshot I've got on the right is actually what comes out of the advertising proxy from the Nest Hub 1.3 border router. So those two aspects that Jonathan talked about, the first is the SRP, the Service Registration Protocol. So our network, and it advertises a Matter record, a Matter TCP record, and it gives it to the Nest Hub border router on the mesh. And then later, you've got your laptop or your smartphone or smart speaker looking to control that bulb, and it asks the advertising proxy, are there any Matter devices? And that's what shows up in this screenshot, which is all of the different MDNS records on my local network. You can see the Matter one that's expanded. It has an IPv6 address, and that address is what's used by the smart speaker, laptop, or smartphone to actually control the bulb. And that's all enabled by the new 1.3 features. And I'll pass back to Sujata, I believe.
I think I'm next. Yeah.
Oh, Gabe, sorry.
Of course. Yeah. So let's zoom out a little bit and just talk about sort of some products and sort of what is Matter. You know, we've talked a lot about Thread 1.3, you know, being sort of in service of the Matter protocol, but we wanted to kind of zoom out a little bit. So we've seen, you know, significant adoption in the last couple of years of Thread technology, especially in the context of Apple HomeKit in the consumer space. And so this slide kind of gives a sense of all of the things that are in market today that are actually using Thread in customers' homes. But we're expecting that to grow even more with the adoption and the ratification of Matter in the next, you know, the coming months and years. So let's see if I can advance the slide. Or if someone else can. There we go. Yeah, so what is Matter? We've talked a lot about it. Matter is an application protocol to connect compatible devices and systems or controllers with those devices. It's really meant to drive interoperability and help device makers get to market quickly with super high quality, very interoperable devices. So interoperability, easier, faster, less costly development for those of you that are device makers, and for end customers, driving faster adoption and sort of simplifying the experience of understanding which devices will work with which other devices, and can I get the experience that I want from a basket of devices when I go to the store. So if we look at kind of the diagram of where Matter fits in the network stack and where Thread fits, Matter is an application layer protocol that, as others mentioned today, sits atop the Internet Protocol or IP stack. And Thread is one of a couple network layers that sort of live underneath Matter and provide it a transport to talk to other Thread-based devices and of course Wi-Fi devices and potentially in the future to the public internet. So Thread lives down there next to Wi-Fi, also next to Ethernet, as another network technology really well suited for low power and lower bandwidth devices. So when we go to the next slide, and when we think about sort of how Matter and Thread fit together, Thread is very reliable with the mesh approach and sort of the self-healing distributed network approach. Thread provides a really reliable base for devices to connect to and connect to each other. Thread is fast, so we already have market examples that you know, if you're a member in the Thread group, we can share of very low latency, you know, very positive customer feedback that Thread meaningfully improved kind of latency and customer experience in that aspect. Thread provides extended range, again, being a mesh. Devices that are mains powered are often routers and will themselves extend the mesh. So as customers bring more devices into their home, the network becomes even more reliable and provides more range. And then of course, efficiency and power consumption. Thread's been designed to support sleepy battery-powered devices, enabling years of operation without customers having to change out batteries. So with that, I think Sujata is going to talk about what is next.
Thank you, Gabe. Okay, so what's next with Thread? So with 1.3.0, we announced that in July. You can see the press release and there's white papers and blogs available to give more information about it. That was also covered in today's webinar, but the focus of 1.3.0 release in July was to support Matter. Matter is targeted to launch in the fall, so coming up soon, and Thread wanted to be ready to support that launch. However, Thread supports other application layers because it is IP based and is application layer agnostic. For example, when we look in the smart building space, there's different types of application layers that are well established for different types of applications in smart buildings. So DALI Plus for lighting and KNX IoT are two examples of application layers for the smart building market that we will support Thread 1.3.0 with. Now, what does that mean for the roadmap? So Thread is a roadmap, has a roadmap. It's driven by members of Thread Group. Thread is a member-driven organization. So the way the Thread roadmap works is it's based on use cases and market requirements. It's not a technology feature roadmap. We develop the roadmap after first looking at what the market requirements are, and companies who get involved with Thread as a member of Thread Group can contribute to and vote on these use cases. We also look at creating other partnerships or additional partnerships for other application layers. And we are looking at expanding to different markets depending on what our members drive forward with. And so if you want to get involved in applying Thread to certain use cases in your industry or within your company and your product portfolio's roadmap, then definitely get involved. We have member meetings twice a year, and some of the roadmap work has already started for after 1.3.0. We will be reviewing and voting on those in an upcoming member meeting in Malaga in October. So to summarize what you heard today from the team of experts here is, Thread was designed from the very beginning to serve as a low power, reliable and secure network in the home and in buildings. With Thread 1.3.0, there were some capabilities added or expanded upon that Jonathan covered in detail around border routers and reinforcing Thread networks and simplifying updates and enabling Matter. And you heard from Gabe and Nathan some examples and Mark about how these get used. And so now we look forward to seeing Thread 1.3.0 deployed in the market, especially with Thread products as with Matter products as Matter launches and is available. Also want to remind you that we do provide a lot of resources to help educate the industry. So we have white papers, videos, FAQs on the Thread Group website. We also have a developer page, that's threadgroup.org/developers, where we list out all the different silicon and system solution providers that can help you get started on developing Thread products. So please do check out the website to get more information. And then thank you for joining. We will still have the Q&A, but to connect with us and stay up to date about what Thread Group is doing, please go to threadgroup.org, and you can sign up for our newsletter. We do a quarterly-ish newsletter that gets sent out. You can also connect with us through social media, LinkedIn, and Twitter, or WeChat. And please do check out our blogs. We promote those on social media, so you'll know when a new blog is released. And with that, we will now enter into the Q&A phase of the webinar. And thank you all for submitting your questions through the presentation. So I think what I'll do is there were several questions around certification. So Tom, I'm going to start with you and let me find, okay, so what is the cost for Thread certification and how long does it take?
Okay, the answer is it varies. Our test labs set the costs, and the costs are generally tied to test time, and test time is generally a function of the type of device, how complex it is. So I benchmark every so often, but I don't keep a close track on it. I've seen numbers around $2,000 for the most minimal Thread device, up to $7,000 or $8,000 for our more complex devices, but that was just some benchmark data that was taken a while ago. Prices move around, as labs come up with different competitive strategies and so forth. In terms of the time for testing, Again, minimal thread devices typically will test within a week. The most complex devices may take 2 weeks, maybe 3 weeks, depending on how many features and the type of testing that happens.
Okay, great. And there's also a smaller fee for Thread Group for processing the certification, but the bulk of the cost is from the ATLs.
Correct, yes.
Okay, one other question about certification. Our platform has Thread 1.1 certification. If we do Thread 1.3 certification, do we do that from the beginning, or is there a quick method?
Again, the answer depends, but in general, if folks are doing 1.3 certification, then they've updated their stack since it was certified for 1.1. So the update basically requires a full redo of testing from the beginning, 1.1, 1.2, and then 1.3.
Okay. And then is there a sniffer tool available from Thread Group?
So our test harness specifies a sniffer device that is in the test bed, but other than that, most, if not all, of the silicon vendors, I believe, have sniffer applications within their SDKs that run on their own hardware. So, you know, Nordic or NXP or Silicon Labs or whoever, I believe also has sniffer capability in their SDKs. So you don't need to use just the harness to do that.
Okay, and then I'm trying to find it, but I remember seeing a question about silicon company certification and how does that get, and how does that help? Okay, if the silicon platform has obtained Thread certification and the device vendor uses the chip instead of the module, in this case, whether the device vendor can obtain Thread certification by inheritance.
Yep, it is possible. There are some dependencies on how the vendor, the silicon platform vendor, has structured their stack and how that was certified, and whether the vendor is indeed, the device vendor is indeed reusing that without any changes at all. In general, the scenario is feasible, but it's kind of a case-by-case consideration.
Okay, and then with regards to border router certification, is the certification simply for end products or also stacks, pre-certified stacks, etc.?
Sorry, I need to look up that one. For end products. It's generally more for end products. Stacks could theoretically certify for border router, but they would be certifying their own implementation, which is probably not, you know, a directly translatable end product type of thing. But if there was a, you know, an intent for whatever reason to demonstrate that capability, they could certify, you know, a reference design as a border router, but it's generally aimed at end products.
Okay, great. So let me switch over to some other questions now. Going back to the top, there was a question, Jonathan, I'm going to direct some of these at you. Will there be an API for over-the-air updates in the future?
Yeah, so that's interesting. The Thread is targeting providing IP connectivity. So typically, over-the-air updates or firmware updates, that's typically handled at the application layer. And if you look at the internet today, there are a number of application layer technologies and protocols that support over-the-air software updates, and including within the IETF, there's even an effort, a working group called SUIT, or Software Update for the Internet of Things, where they're trying to standardize a protocol for over-the-air updates over IP. So, you know, I don't think it's necessarily within scope of Thread, but given that Thread supports IP, it also does help support any IP-based firmware update protocol running on top.
Thank you. And then another question about audio. Does Thread support audio? If so, what is the audio quality?
Yeah, so you know, generally Thread is an IP network that's capable of transferring a certain amount of data. That amount of data is lower bandwidth than Wi-Fi, so you know, typically single-digit kilobits, maybe double-digit kilobits per second. You know, in certain environments. So it really kind of largely depends on what your audio requirements are. For a highly compressed audio clip that may not have low latency requirements, then maybe it could support those applications, but certainly like high quality or lossless audio, that's probably not an application that's targeting for that Thread targets.
Okay, and then a little bit different, but let me throw this at you too, Jonathan. Are there any differences or affordances in the 1.3 spec for different classes of border routers? More specifically, Linux class versus microcontroller class, where resources are limited?
Yeah, not today. So what the Thread spec does provide are a minimum set of requirements, right? The number of children a border router needs to be able to attach, the number of service registry entries that it needs to be able to handle, right? Those are minimum requirements, and so that kind of sets the baseline. Certainly for border routers that have more resources, more capabilities, they're more than welcome to go well beyond those minimum requirements. But I will mention that the OpenThread border router, for example, has been demonstrated on RTOS class devices from some of the silicon vendors already. So it is possible to support Thread 130 border routing on an RTOS class device.
Okay, great. Gabe, let me ask you this next question because you're building products and deploying them in the market. At what latest stage of product development do you recommend initiating the steps for Thread Group membership, Thread Group certification of the product in order to avoid any delays in product launch?
Yeah, so I think my off-the-cuff recommendation is to engage no later than about a quarter ahead. So three-ish months ahead, but obviously sooner than that or earlier than that is always better. I think one thing to really keep in mind as you're joining the Thread group is that I work at Amazon. Like joining standards bodies on behalf of Amazon is a really complex process, and so that alone could take 6 months. So it's sort of dependent on the size and scale of your particular company. But yeah, once you join, Tom coordinates tutorial sessions on sort of how to go through CERT, and you'll have access to all of the tools that basically show you how to run CERT, and then you have to go contract your lab and get scheduled. So 3 months seems possible, but you probably would want more.
Thank you, Gabe. I see also a few questions around Bluetooth Low Energy for commissioning, like do Thread devices need BLE for commissioning? Do Matter over Thread-based devices need BLE for commissioning? I think there's another question, a couple of questions around Bluetooth Low Energy and Thread and how it gets used. So Nathan, would you like to take those questions?
Sure. Yeah, I can take a stab. So yeah, I think Thread devices today don't require Bluetooth. Commissioning over Bluetooth is not standardized in the 1.3 spec. There is a method to commission devices without Bluetooth or just Thread alone, and it's called the joiner protocol or mesh commissioning protocol. For Matter over Thread, they opt not to use that today. They use a proprietary Bluetooth commissioning method. So yes, Matter over Thread today does require Bluetooth. Future things in Matter, you should probably be referring to the CSA group. I think I covered most of those questions.
Yeah, I think so. Thank you. Another certification question, Tom. Once a product is certified, how long does the test data last? Does the product need testing annually?
Okay, so I take that as how long does the CERT itself last? The CERT is basically as long as the member is within the group, and that is subject to the board deciding that there is a across-the-board spec revision that needs some kind of testing update. We don't currently have such a thing on our radar, but that would be the kind of the clause that would require a retest. There is no specific retest other than if you are updating your software, you should retest.
Great. There's a question in here about sub-gigahertz. Let me find that one. So what I will say is that Thread today is a 2.4 gigahertz technology. As I mentioned in the presentation, Thread Group is continuously evolving the spec via its roadmap to address more use cases. We are in a period of evaluating new use cases. And when we talk about sub-gigahertz, that would be the solution. So if you have interest and see a need in sub-gigahertz and Thread, I highly encourage you to get involved with Thread Group, because we are right now in the middle of defining what kind of use cases require sub-gigahertz. And we have our member meeting in Malaga, Spain. So a really nice place to visit, October 25th through the 27th. Registration is open now through October 17th. So if you're interested in sub-gigahertz and Thread, please get involved there. Okay, so I see a couple of questions also about how do you put a Thread stack on a mesh device, and can it be used on an MCU development board? So Mark, why don't you take those questions?
Yeah, sure, I can provide an answer. So on the microcontroller-based devices, if you're trying to add, Thread mesh capability, certainly a number of the leading silicon vendors all have really good development kits there to utilize, and as well the tools. Also, I know from experience, we've leveraged some of the projects in the OpenThread project itself, and even leveraged some of their border router reference projects, like with the Raspberry Pi, so you can get the border router set up pretty quickly. So you actually have something to then join your new Thread device to. And then certainly, as you become part of the Thread group, we very heavily also utilize the standard test tool provided by Tom and team, and that lets you run through all the different test cases. And as well, what's nice is there is some flexibility in the tool now. In some of the newer versions, you can actually pick through some of the different versions of the Thread specification, and then that changes the test cases. So those are all kind of three different key ways that that we utilize in order to test the border router and the different mesh end devices.
Yes, and I can say, I mean, I'm supporting Thread Group, but my day job is NXP Semiconductors, and we build wireless MCUs, and so the Thread stack is implemented as a software enablement that runs on wireless MCUs. Okay, so looking at, let me see, I'm not sure, I'll just open this up to our panel here. Is there a limit of mesh end devices installable in a Thread mesh network? Are there examples of thousands WSN end devices installed in fields? Anybody want to take a crack at that?
Yeah, I could mention today we actually, something we've built at MMB is something we call the device farm. We actually have many IKEA bookshelves spread throughout our office, and each one has dozens of Thread end nodes. Currently, the border router we're building can speak to around 100, and our end goal is going to be something about 200. So 200 end nodes is definitely achievable. I think the question mentioned thousands as well. I mean, really what ultimately, or I say one of the leading constraints in the size of these networks is the amount of bandwidth that the network is going to use. So the more chatty and the more data that's flowing from the nodes, let's say, to the border router out to another IPv6 segment, that will, reduce the size of network you can practically build. Of course, the opposite way, if you had a network that was composed mostly of sleepy devices that really only speak, or send out data maybe once a day or once a week, then you can definitely scale up much larger networks that way.
Thank you, Mark. All right, then I also, lastly, we are running out of time here. So the last question, I saw a couple of questions about Thread border router and implementing border router and software size. Jonathan, Mark, I think both of you have some, maybe even Gabe too, have experience in that. Can you share some information on your experience?
Yeah. I'm sorry.
Go ahead, Mark.
I mean, my answer is probably quicker or less detailed than Jonathan's, but I can say our BRD21 product today that we showed on the slide is an RTOS-based product. So we are able to implement the key 1.3 features with that. I will say it's not necessarily without certainly some work to make sure it fits on a much more constrained platform than Linux, but I can say it definitely is possible.
Thank you, Mark. Jonathan, do you want to add to that?
Yeah, I just was going to say basically the same thing, that Thread 130 border router features have been demonstrated on an RTOS class device. Obviously, also demonstrated on Linux class devices. But if we're talking about can border routers fit on very constrained microcontrollers like an RTOS class device, then I think the answer is yes, as Mark mentioned.
Yes, and that's my experience with NXP too, because we have Linux processors and MCUs, and can definitely see implementing border routers on both. Okay, well, with that, thank you to the panel, the presenters, so much for sharing your insights and knowledge and experience about Thread. Thank you to all of the attendees. I hope that you learned more about Thread 1.3 and how it's used in the industry with Matter and other devices. And also thank you for the great questions. As a reminder, this has been recorded and will be available on the Thread Group website. We will send an e-blast when it's available to the attendees so you can access it. And again, we'd love to see more of you involved in Thread Group. Having members really drives the success of Thread. And so please check out threadgroup.org and join us, whether or not you can do it in time for the Malaga member meeting or not, sometime shortly after. Thank you, everybody.